Hey everyone, welcome to The Explainer. Today, we're giving your electronics the gift of sight by exploring the ultimate digital eye, the LDR light sensor. Let's teach your projects how to actually see what's going on around them. Here is a quick roadmap of what we're covering today. First, we'll meet the LDR sensor, then compare its digital and analog pins. After that, we're wiring it up to an Arduino R4, calibrating its sensitivity, and finally, looking at a really cool smart nightlight project. Okay, let's dive into part 1, meeting the LDR sensor. So LDR stands for light-dependent resistor. Basically, it's a neat little sensor module that acts exactly like an eye. It helps your Arduino easily understand the lighting conditions in whatever room you put it in. Now check out that squiggly little component right on top of the module. That is the magic ingredient. It physically reacts to the light bouncing around it, which changes its internal resistance based on the brightness. And you know, the board itself is super user-friendly. It comes with 2 handy little indicator LEDs. You've got a power LED, so you know it's on, and a digital out LED that actually lights up based on the sensor's current status, which makes testing it a total breeze. Moving right along to part 2, let's talk about the module's dual personality, digital versus analog pins. You basically get 2 entirely different ways to read the light. The digital DO pin is straightforward. It just shouts high for dark or low for light. It's a simple yes or no. The analog AO pin, on the other hand, gives you a broad spectrum of exact numbers showing highly precise brightness levels. To put that into perspective, if you take a reading from the analog pin and get a really high number like 1013, well, that means your sensor is sitting in the pitch dark. But the second that plenty of light hits it, bam, that analog reading drops significantly down to a low number like 145. It's an incredibly precise sliding scale. All right, part 3, let's head over to the workbench and actually hook this thing up to an Arduino UNO R4 Wi-Fi. It takes just 4 super simple connections. First, connect your VCC to the 3.3 or 5 volt pin. Second, connect ground to 0 volts. Third, run your DO line to a digital pin. And finally, connect AO to an analog pin. Easy, right? Now, what's really interesting about this next part is how we can physically tune the hardware. Let's look at calibrating the sensor's sensitivity. See that little blue box with the screw on top? That's your sensitivity dial, or potentiometer if you want to get technical. You literally just take a small screwdriver and twist it to tell the digital pin exactly what level of brightness should be considered dark or light. So as you turn that dial, you're actively changing the light threshold, and you can actually watch the DO-LED click on and off to visually confirm it. Just keep in mind, this is absolutely crucial. Turning this dial only affects the digital pin's trigger point. It won't mess with your precise analog readings at all. Okay, part 5. Let's bring everything we just learned about the LDR together and apply it to a fun, practical example, a smart night light project. And really, that's what it's all about. The LDR transforms the raw environmental light around you into actionable data for your projects. The nightlight is just one example of what you can do with this awesome little sensor. Please subscribe to the channel, like, and share.